Hello friends, today we are going to study the topic of circuit switched fallback, which is generally called as CSFB. CSFB is basically a most widely used phenomena in LT networks for the continuity of CS services like voice calls, both mobile originating, mobile terminating, and SMS as well. So let's have a deep look into this topic. The background is like this, that CSFB basically enables the LT subscribers to simultaneously register with EPS and CS networks and at the same time fall back to CS network as instructed by the APS network to use the CS services as I just mentioned for voice call and SMS. So basically, there are two modes for implementation. One is called the standard CSFB mode, and the other is called the CSFB proxy solution. So, what benefits actually we are going to get? The benefit for CSFB is that carriers can reuse the existing CS infrastructure to provide CS services for LT subscribers, thereby reducing the workloads for reconstructing the networks. As we all know that basically the 4G network is basically a data network. It is not meant for conventional CS services like voice and SMS. So by using the CSFB phenomena, the subscriber can fall back to conventional 2G, 3G network and thereby use the voice and SMS services and USSD services. So CSFB is basically a faster solution for the deployment of 4G networks and at the same time continue to use the legacy CS services. So whenever a call is placed by or to subscribers registering with LT network, the subscriber will fall back to CS network. This movement of subscriber from 4G network to conventional 2G, 3G network is basically called the fallback phenomena. So let's have a deep look into it. The standard CSFB solution is a solution in which it is required that all the MSC servers connecting to the LT network should be upgraded to support the CSFB deployment. As we can see over here, like whatever MSCs are deployed in the network and are interfacing to the 4G LTE network must be upgraded to support the connectivity with the MME. In this case, we will be having a new interface and a new port protocol which is called the SGS interface, and it has the SGS application part associated with it. So the MSC server, which is handling the 2G and 3G traffic, should be upgraded or should be equipped to handle this interface and have the capability of handling the SGS application protocol. The other solution that is normally used, that is called the CSFB proxy solution. CSFB proxy solution requires that MSC server that supports the SGS interface be deployed to function as the CSFB proxy. In this solution, only simple CS network reconstruction is required for CSFB deployment. What does that mean? It means that if the operator do not want to upgrade all the MSCs to support the interface between the 4G network and the conventional network due to any constraint, then only few or one of the MSC server can be upgraded to support this interface, which is required to have the registration of subscribers both on the LT network and the CS network, and this proxy server can be used for subsequent connectivity to the legacy 2G and 3G network. So this is called the CSFB proxy solution. Let's have a look at how a basic CSFB voice call takes place. In this case, we see that user equipment places a call via 4G network towards the MME. So after receiving a voice call, a service request from the UE is received at the MME, and the MME asks the subscriber to fall back to 2G and 3G network, which is mentioned over here. So fallback as a whole is a process in which the subscriber or the UE fallbacks from 4G network to legacy 2G and 3G network. And once the subscriber falls back to 2G and 3G network, the MSC server follows the basic CS call flow to continue processing the call, which we are already well aware of. So this is the process of basically mobile originating call. Now, if we talk of mobile terminating call, so what happens in that case is that after receiving a paging, the MSC server pages the UE over the SGS interface, so that whenever there is a mobile terminating call on the MSC server, the MSC server receives the uh, provide roaming number request. Then on receiving that request, the MSC server pages the subscriber over the SGS interface towards the MME. So on the MME further pages the subscriber over the LTE interface, and once the subscriber replies back to the MME, then the MME instructs the UE to fall back to the 2G and 3G network, and thereby the call is being handled similar to the normal 2G and 3G call flow. Then there are certain mechanisms which are being used to ensure the functionality of the CSFB process. One of this functionality is called the CSFB redundancy. The CSFB backup and redundancy feature basically enables that a standalone or pooled VMSC server to interwork with an MME or an MME pool. So what is basically this redundancy or backup? The backup is that in case of a pooled scenario, one MSC basically backups the data from another MSC, so that in case of any disaster event, that if that MSC goes offline, then the other MSC also has the backup data in that available in it, so that the service continuity can be guaranteed. And there is another process which is called the empty recovery, in which in case if the MSC is not available, then the STP can send the provide roaming number request to backup MSC, and the services will continue. Similarly, in case of MME pool, if any MME becomes unavailable, then from the MSC server side, the connectivity or the request will be sent to the standby MME, and in this way the redundancy can be ensured and the service mechanism can be continued. In addition to the CSFB redundancy, the CSFB proxy redundancy is almost similar. In case the proxy MSC servers which are interfacing towards MME, they uh, act as backup to each other and provide the necessary redundancy mechanism, which is exactly the similar phenomena as we have just seen in case of normal CSFB phenomena. So now let's have a brief overview of the protocols and interfaces. As I mentioned earlier, that the interface between the MME and the CS network is basically called the SGS interface. This SGS interface basically serves the SGS application protocol and is used for mobility management on EPS and CS networks, service data transmission, and paging during the voice calls and SMS. Similarly, the interface between the MME and the EUTRON or the 4G RF network is called the S1 MME interface. This interface basically serves the S1 application protocol and is used for signaling transmission over the air interface. Then we have the S6A interface. This interface is basically between the MME and the HSS. This interface basically handles the diameter protocol and is used for subscription and authentication data transmission between the MME and HSS, which is a conventional authentication mechanism for any kind of subscriber registration. Now let's have a look on to some of the key techniques that are used in CSFB mechanism. One technique is called the MTRF. The MTRF is basically a technique which enables for increasing the call completion rate increase. Why this is used? Because as we know that in case of CS fallback, the basic mechanism is that a UE or subscriber basically changes the radio access network from 4G to either 2G or 3G. So in this case, there can be several challenges while the selection of the new radio access network or camping on the MSC in the target CS network. So in order to enhance and guarantee the call completion rate, this feature is used. This feature basically enables the original MSC server to route the call to new MSC server, thereby ensuring the successful connection of the call in case the uh, location area is being changed. Similarly, in case of CSMT, the same technique is being used for increasing the call completion rate and is more sort based on the same phenomena. So now let's come to the fast return. So what is a fast return? Fast return is basically a process in which, just like the CS fallback, the subscriber returns from 2G 3G network to 4G network. What happens exactly is that whenever the PS connections are unavailable after a CSFB call is released on 2G or 3G network, then when attempting to release the call, the MSC server adds the CSFB indication information element to the clear command message which is sent to the BSC, or in case of 3G, it adds the end of CSFB information element in the IU release command, which is being sent to the RNC. So whenever RNC or BSC receives this information element, then it considers that this subscriber is basically a 4G subscriber or a CSFB subscriber, and the BS and RNC should take action to move this subscriber back to the 4G network. So in this way, it can differentiate basically a CSFB subscriber. So there is another scenario in which when the PS connections are available after a CSFP call is released on a 3G network. So what actually happens, there is another phenomena that is called the PS handover or redirection. So by using this mechanism, the RNC basically can serve as the anchor for the UE to move back to the 4G network. So now let's discuss very quickly the message flow for a mobile originating call in case of CSFB. So whenever the subscriber dials the call, then a message which is called the extended service message is being received as the MME. So first the MME when the MME receives this message, then an indication of service request is sent to the serving associated SGS associated MSC server. This is an optional message. It can be disabled or enabled, but it is good to have the visibility at the MSC side in terms of statistical visibility. So once the MME analyzes this service request, then it uh, directs the E node B to initiate the fallback mechanism, which the E node B using the RRC connection release message on the air interface instructs the UE to fall back to the 4G network. Then the UE falls back to the MSC server and initiates the normal process of call. In this case, there are certain other messages which we are not going to discuss over here, but are being just mentioned over here, that in case if the MSC is different from the normal MSC on which the subscriber was already registered via the SGS interface, then what different messages will be shared. So this call will basically the normal call as being followed on the 2G or 3G network. Similarly, in case of while terminating call, when the PRN message is received at the MSC, then the MSC will be initiating the paging request towards the MME, and the MME will be sending a paging request over the air interface. And once the UE replies back to MME for the paging response, then the MME will be instructing the UE to fall back to the 2G and 3G network, thereby the normal call as followed on the legacy network will continue. So this was a brief description of the circuit switch fallback. Later on, we will be discussing the MOMT calls in more detail. We will be dissecting the complete messages in detail and will be having the view of information elements. So please stay tuned, keep learning and subscribe to our channel. Thank you.